to it today.
Thank you, Emma, for the introduction, and thank you everyone who joined this meeting. And I'm so glad to be able to deliver and share some knowledge about Azure Cognitive Services. So let's get this started. Yeah, so this session is about democratizing AI with Azure Cognitive Services. My name is Peter Örnholm. Here you have my Twitter handle and everything like that. I'll get back to me shortly. But let's get back a bit before that. I'm not sure if anyone of you are reading the XKCD comics that floats around the internet. I really enjoy them. And I think it was roughly a year ago I was stumbling upon a few of these, and especially this one. It says, when a user takes a photo, the app should check whether they are in a national park. And the developer answers, sure, easy. This is a lookup, and give me a few hours and I'll be done with that. And then the product owner asks, and also want to check whether the photo is of a bird. And then the developer answers, I'll need a research team in 5 years. And what this states is, in computer science, it's hard to explain the difference between the easy and the virtually impossible. And this was released September 2014, so roughly 6 years ago. And the comic says that they would need 5 years to actually find out whether or not an image contains a bird. So I thought, how many years or how many hours do I need to fix this? And I also wanted to check what would it have cost them to do this. So I looked at the average salary for a researcher in US, and that's roughly $77,000 a year. And to be a team, they need about 3 researchers, so that's $232,000. And in 5 years, that would sum up to about $1,160,000 US. And that's a lot of money to figure out whether or not an image contains a bird. So I thought, what tools are available out there? Haven't we got so far that we can make this much easier? So let me introduce to you a site called birdornot.net, which I've built. And I built this site to prove that nowadays we can solve these things with much less effort and much less time and money than it would have taken just a few years ago. And I'll show you a demo. Let's bring up the site here. So you can navigate to this yourself, either now or after this session. So this site, you provided a link to an image of a bird. Let's take a hummingbird. And then you provide an image. It identifies that within this box there is a bird. It is a bird, and it also finds that it's a hummingbird. And it's 90% accurate or sure that this is a bird. Let's take let's just Google for a bird and take something we can find here. So let's take this one. I'll just let Google take the link to this one, and we run the identification. I didn't fetch that, but let's take the penguin instead. So here it is. It's a penguin. We can also take an alligator just to prove that this is not a bird. And this is just a sample of things you can do with AI, and especially democratizing AI. What I mean with democratizing AI is that everyone can build sites like this. Everyone can take advantage of AI and machine learning to identify birds and other animals in pictures. So let's get back to my presentation. So I just want to show you, it didn't take me 5 years and $11 or $1 million to find out this. It took me roughly 5 hours to build this site, and a large portion of that was actually styling it and making it look nice. And each API call I do to Azure to find out whether or not it's a bird cost me about 0.05 kroner, and that's roughly $0.005, I'd say. So it cost me almost nothing. It's really fast to implement, and this is what I want to show you, that for 5 years ago we thought that these things were nearly impossible. It would take a team, a large amount of money and hours to do, and now every developer with the knowledge about how to use cognitive services can actually do this. And my name is Peter Arneholm. I am a Microsoft MVP, previously within Azure, and nowadays within AI. And I run Azure Stockholm. It's a user group where we share knowledge about Azure and AI. And I work as a consultant and marketing manager at the consultancy company Active Solution in Stockholm. And at Active Solution, we help our customers with Azure, AI, and development, and build custom solutions for them. So let's have a look at machine learning and AI. If you're new to this, I would say that there is a broad spectrum, and the definition, there are a few definitions, and I won't go into details of those, but I would say that there is a broad spectrum of what we call AI and machine learning. On the one end, we have kind of the more, so to say, theoretical parts of it. We have the papers, and we have the universities, and we have the kind of the cutting edge people who looks at the theoretical parts and so on. And on the other hand, we have the consumer, close to the consumer, basically, for example, an Amazon Alexa or Siri in your iPhone and so on. So basically digital assistants and things like that help you out in your everyday life using AI. It might even be the spell checker in the Word that uses AI nowadays. And somewhere here in between, we have, for example, ML.NET, which is a .NET library for working with machine learning. But a lot of the kind of things to the left here, they require you to have your own data sets. And if you want to get started really quickly, for example, identifying a bird in a picture, you need to have pre-trained models. And that is what Microsoft provides with Azure Cognitive Services. So Azure Cognitive Services enables you to get started really quickly without having to train your own machine learning models. And Azure Cognitive Services actually comes from experience from within Microsoft. So Microsoft themselves have the need for machine learning and AI in their services because they are building Office, Windows 10, Xbox, and Bing. And all of them need to use AI and machine learning to be cutting edge. For example, in Bing, you want to index, if you want to index all of the images on the internet, you want to index them and know what's in them. So therefore, you need to know, is it a bird in this image? Is it a car, or what is it? In Windows 10, you want to have like antivirus detection. You want to find anomalies and so on. And in the Office suite, you might want to present different ways of styling your PowerPoint presentation or things like that. And the cool thing here is that a lot of these, Microsoft starts building services and it starts building things that uses AI. And they realize, okay, other companies and other people might want to take advantage of this and use them in their own products. And therefore, they have made cognitive services, which a lot of them are based on things that comes from their own products. And cognitive services is divided into multiple categories. We have the visual category, language, the speech, and decision. And each of them have different services within them. And I'm not sure, there might actually have been added a few services since I did this last time. So within visual, we have the ability to identify things in pictures and so on. Within language, we are able to understand language. We do have language understanding to understand intent. If you tell your digital assistant, turn on the lights in the living room, you can understand what is the intent of that saying. With speech, we can understand the voices, we can take text into voice and so on, and we can recognize different speakers within an audio file. And with decision, we can see, are there any anomalies in this data? Are there content moderation? Do we need to moderate what's uploaded to this site or things like that? And Personalizer can be used to make personalized experiences on your website. And cognitive services, I said, they are split into multiple categories, and by default they are all hosted in Azure, in the public Azure cloud. So it's really easy to get started. You just create a resource and you connect to that resource and you're up and running. And they are exposed over HTTP APIs. And for the most common languages and platforms, there are SDKs available. So you get a really smooth start with a typed interface and so on. And under the hood, a lot of these use AI and machine learning and different algorithms to provide you the best result for what you need. And that's one of the things that makes it democratizing. You really don't need to understand all of the mathematics and all of the things under the hood. We can get back to why you actually should do that in the long run, because there are problems that can appear if you don't actually care about exactly how this is done, but you can get started really quickly. And nowadays, it's not only hosted in Azure, you can actually host a lot of these in containers. So if you have the need for compliance reasons, maybe to run it locally, or you have reasons because of latency, you want to have really fast answers, you can run it locally. So for example, we have scenarios where we want to detect what people are saying, and we don't want to send that because of latency. We don't want to send that to the public cloud, identify it, and then send it back. We want really, really fast responses, and then we can run it in containers instead. And this session will be more of an inspiration than actually digging into code. I know that a few of you actually probably know a lot about code and so on, but I also know that you are smart enough to go into the deeper resources, and I will actually provide a link at the end for more information on that. But I'll just show you a quick brief on how it conceptually works code-wise, but then I let you explore the details on the code yourself. So just to explain how the site Bird or Not was built, I was creating a service in Azure. And then I was saying, hey, from my code saying, hey, I want to analyze this image. I give it an image URL. I say, I want to find objects within this image, and I get back an image analysis result. From the image analysis result, I can check, were there any objects that were named bird? And if so, write that out on the website. I know there are a few more things to the website. It's some styling and things like that, but conceptually, this is how easy it is to do these kind of things. So most of the rest of this session will be a demo. And as I said, please write questions in the Q&A. There is some latency from me actually presenting it to you actually hearing what I'm saying. So the questions appears 1 or 2 minutes after I've been talking about it. So I will summarize all of the questions at the end and go back and answer them. But please write questions, and I'll make sure to answer them at the end. So from now on, most of the things will be demos, and we hope that everything holds together. So I'll start here with, I'll continue. There will be a lot of vision-based demos today. So I've already showed you the Bird or Not site, but to do some more generic stuff, I've actually built something called Cognitive Workbench. So Cognitive Services is a set of services and a set of APIs. And if you are familiar with APIs, they're usually they're really, really good because you can integrate them into your own services. But the boring part is that they are very technical and they are very non-visual, so to say. You send in text and you get back text. So I built something called the Cognitive Workbench, which is an open source project where you can try out the different APIs yourself to actually get a look and feel on how they are working. So we'll start with the computer vision part. And I'll bring an image here. So here I have an image of a place in Sweden called Umeå. So I was there. Now it is actually more than a year ago, and it was one of the last. No, it was roughly 1 year ago, and it was one of the last sessions I did live before COVID hit the world. So I took this image before my session. Let's see what Azure Cognitive Services can find out about it. So we'll let it analyze the image. So now, to start with, let's look over here. To start with, it has automatically created a caption of the image for me. It says, a truck is parked in front of a building. And this can be very valuable for accessibility reasons. So if you have if you can't see 100%, you really would like to have caption of images on websites. But from experience, I know that a lot of people and a lot of companies doesn't always provide a good caption for their images. And this could be a good start to kind of provide an automatically generated caption of an image. And it says that it's 93% confident of this caption. It also creates a few tags of the image, saying this is a building, this is outdoor, it's a truck within the image, there's a street, and we also get some tags with confidence levels. Sorry, my Apple Watch just called some random number here. but also, as you saw before, I was able to identify where in the image is there a bird. In this case, there are no birds in the image, as I can see, but it has identified that there is a van in the image, and you can see it here. And if we drill into the details, because this is just a visualization of it, but if we drill into the details, we can see the exact coordinates where the van is. We can see that van is part of the category car, which is part of category land vehicle, which is part of vehicle. So we get a few of those really interesting metadata. And let's see, let's just take some random image on the internet. Let's see, let's find, I know Microsoft is located in Redmond. Let's try to see if we have any images of Redmond here. Let's take this one. This is just, and we'll try to analyze this and see what it identifies about this one. So this is really interesting because now it's also trained on some well-known brands. So in this case, it says, I've identified that within this box, there is a brand, and that brand is Microsoft. So it's trained on kind of international and large brands. So that could be useful to identify them. And a lot of this information could be really useful to index. If you have a large amount of images and you want to index them and maybe search them by tags or search them by text, or find me all of the images that have Coca-Cola in them, for example, you could use this technology. Let's see if I have something more. Yeah, we could take, let's take this one. And also, I know this, theoretically, this technology have been around for ages, but computer vision also has OCR. So, for example, the caption for this is, there is text in this image. And it's a sketch, it's a cartoon, it's a drawing, it says. Let's go down here. If we, so here we have it. So here is the text extraction of this image, and it's really, really good. So I've noticed, I've done this in a few projects and seen that there are differences between how OCR worked 10, 15 years ago than how it's working today. And I'm really impressed by this. And this could, of course, also be used together with other techniques to example, extract the text, and as we will look at later on, do text analysis on that text. But then let's round up this demo with an image of me. So here it is. I think it was 2 years ago or something. It might be in the peak of my speaking career. I'll show you the image while it's analyzing it. This is an image I took from Instagram because I created it. I was actually speaking in this case, I was in Oslo on the Tuesday. I was in Denmark on Wednesday and Stockholm on Thursday. I was speaking on 3 different Azure related conferences. Let's see, I'll just refresh this one and make sure that it analyzes it. There we go. And so I was delivering the session, basically going to the airport, flying to the next town, delivering a session there, sleeping and going to the next town. And one thing that Cognitive Services computer vision can do for you is find faces and take a visual kind of a guess on the visual age of you. And if you ever wondered if you get older by traveling and speaking this much, I can show you. So it identified that on the Tuesday I was 28 years old, on the Wednesday I was 30 years old, and on Thursday I was 34 years old. So I guess not traveling so much during COVID times is quite good for me. And let's bring up the next service within this one, and that is custom vision. Because a lot of these models, as I said, Microsoft provide you with pre-trained models that let you get started really quickly, and they are trained on data sets that Microsoft provides. And that enables you to identify sunglasses without training it yourself and so on. But sometimes you really do want to train it yourself. So let's go to custom vision. So Microsoft enables you to build a model that is based on the kind of the new generic models, but then allows you to add your own kind of domain knowledge and your own specific images and train it on your own specific data. So in this case, if you have ever, I'm not actually sure what the name of this game is in English, but it's bull in Swedish at least, and I think that originates from French, if I'm not wrong. And in this case, I was playing this game with a few friends, and we came into kind of this discussion: who is the closest to the jack, to the little red ball there? And I was starting to think, can't we solve this with AI and computer science, and basically take a photo of the playground and the play field and let it identify the different objects and then calculate the distance to them. But I noticed that the generic computer vision model didn't identify the bulls and the jack. So I was actually training a model myself. I searched around on the internet and found quite a few images of these kind of the bulls and jacks. And what I did then, let's take this one. So what I did was to train it and uploaded a few and made squares around that. This is a bull, this is a jack, this is a bull, this is a bull, this is a jack. And you tell it you show it about 15 images at least, and it will start to recognize them. So if you then make a quick test and enter a URL, in this case, an image I took myself, it can identify that this is a bull, this is a bull, this is a bull, it's 94%, this is a jack. Then it thought my feet were bulls as well, but it's only 61%. So if we increase the threshold to only include things over 75%, we actually get quite accurate results here. So with this, I want to show you that you can train these models yourself. Maybe you're not satisfied with only knowing that this is a car. Maybe you want to know it's a Tesla or if it's a Volvo, and then you can train it on different car models. And I have a colleague, Alan Smith, that is also a lot into AI in Azure, and he have quite a good set of videos on YouTube on how to use custom vision. So please check them out. Alan Smith on YouTube. So let's move on, and actually I will go back a bit to the faces part, because what I showed you here was the generic computer vision model. But if you're specifically into knowing more details about faces, you can actually drill into the face API. And I'll get you, I'm not sure if everyone is from Sweden or if you're from around the world, but I will show you an image of our king. So this is the Swedish king, and this is the face analysis of him. So he is, according to this model, 100% happy. He is 67 years old. He doesn't wear eye or lip makeup. He smiles. He has a little beard and a little mustache, it says. And as you can see, it also identifies different points within his face. So you have the left pick, like what's the coordinate of the mouth left? What is the coordinate of his nose tip? What is the coordinate of his eyebrow left outer, and so on. So you get a lot of that metadata. Let's see if I have some more interesting picture. I can actually take this one. This is also another picture of me and my daughter when I was presenting at the Microsoft conference a couple of years ago. So this is me. This is my daughter. It thinks she is 1 year old, and she was roughly 1 year old at the time. She's very happy, and yeah, no mustache or beard for her. So that is really interesting, and I'd like to show you a little demo on this one. Now I will have to disable my Teams webcam for just a few minutes while I show you this demo. So I'll not stop sharing, but I'll turn my camera off, and I will see if you can. Let me see if I can get hold of the. Okay, I'll have to just reconfigure my headphone here. I think that's the one, and I will do this. So I'll disable my camera and I'll go to another demo. I hope you can still see my screen. I created this demo called cogbox.net. It's a cognitive jukebox, a jukebox enhanced with cognitive skills. So what this will do, it's a completely, it's a website you can use. It's open source. It's all of it, and basically all of what I'm showing you today is available on GitHub as open source. So you can play around with the source codes yourself and try it out and fork it and do whatever you want. And this specific demo uses the face API to try to identify the visual age of me. Then it goes to the Spotify API and asks Spotify, hey Spotify, do you have any good albums from when Peter was born, or when I think Peter was born? And then it will play a song from that album. And it's always, because this is live and it's not in any demo mode, so everything can show up. Bear with me while I try this out.
You look like 27 years old. I will play Knockin' Da Boots by H-Town. A great album from 1993.
Yeah, I hadn't heard about that album before, but it usually works, and I'm soon to be 30 years old, so it was a bit it was nice to me to say I'm a bit younger than I actually am. But this I've seen, it's really funny. I've seen quite a lot of people share this on Twitter and on social media, and they tend to share it even more if it thinks they are younger than they actually are. But it's just a funny demo to show you the potential of this service. And I'll go back and actually share my camera again. I hope you can soon see me again. I think that, yeah, now I'm live again. Thank you. So let's have a look at, yeah, we can actually do another demo on faces. So what you can do, and I know this is, there's a lot of debate about this, and it should be used with responsibility and with care. What you can do is to identify, if you train your face model on specific faces, you can use that to identify a person and to verify that someone says who they are. I know, for example, Uber is using this to identify the driver. When the driver sits down to actually drive, it identifies that the one behind the the one who drives the vehicle is the one who owns the account, so to say. And I've used this, I trained this on a few Swedish political, because Swedish Swedish political people in Sweden are public people, and they are like usually in the news and so on. And if you're, let's say that a use case could be, if you're reading a news article and there is a picture of someone, and there's a picture of someone who is a public person, you might want to know who is this one. And if you have a hard time seeing images, that could be really useful. So I've taken this. Here we have an image. This is an image from one of the Swedish news article. And I think two of these people are actually politicians in Sweden. So if I send this in to my model, I'll then enable identification. We can see that in this case, it has identified this person as Daniel from the Vänsterpartiet, and it has identified this woman as Kristina Axén Olin from Moderaterna. And this is trained on only one image, and it can be used, if used responsibly, it can be used to, for example, in your phone, you usually have this. This is my photo library. This is my father. This is myself. This is my daughter. This is my wife, or this is my husband. And then you can identify and group images per face, so to say, to easily get access of a specific person. So that is the technology that drives this. Let's move on and see what's next in our demo catalog, so to say. Yeah, I'd like to show you a demo here of Personalizer. So we'll actually do one last thing regarding video. And this is also within, it's close to the other things, because if you can identify things in images, then video is just a series of images. But instead of you having to do that yourself, I think it is here, I should log in. They have made a service called Azure Video Indexer, where you can upload videos and it will analyze those videos for you. So here's a talk. I realized a lot of my demos are based on talks I'm giving throughout the years, but they usually have publicly available material that I can analyze and present. So this is a session I did in 2018. It's a video that's available on YouTube. So I uploaded it to the video indexer. And what this one does then is to analyze not only what's in the images, but I can show you, for example, we have a few labels. So here it says, I've identified laptops in these places. I've identified electronics in these places. We have emotions. So I have a bit of fear in the beginning, and then I have joy. I hope that I end up with more joy than fear, at least. And it finds keyframes from the video. But not only analyzing the images, it also analyzes the audio. So if let's see, for example, I think it's over at timeline. So here it has done an automatic transcription of what I'm saying. So this is a video where I'm talking in English. So we can actually enable English captions.
Especially secure.
So this is
the Azure portal for exploration, because it's a great way of finding out new stuff. For example, new security features that they have enabled.
So as you can see, it's quite good at actually automatically identifying and putting captions in my video. And this is just a nice UI on top of a lot of APIs. So you can use this yourself if you have a video service, or if you want to kind of extract what's the captions for this one. And when used in combination with the cognitive services for translation, you can actually enable translations into other languages. So if we enable because we are running this at Stockholm event, so now it's translated the captions the closed captions into Swedish, and then I can enable the Swedish one. So now,
to be really secure throughout your application, you should probably automate a lot of the stuff we will be doing today. But you are smart enough to find the documentation for PowerShell.
So now a few of these ones are like, when I'm talking about ARM templates, it translates that into biceps, basically, which is funny because of the new language called biceps. But it's quite good, and it makes things much more accessible than they would have been without these kind of services. So that's really interesting. Let's move on to, I think this is the one. So let's move on. I've been showing you quite a lot in the category of vision. I've been showing you computer vision, face recognition, a video indexer, and so on. And there are a few more things there. There are form recognizer for extracting information about from forms and PDFs and so on. But I'll move on to the decision category. And one of them are Personalizer. So Personalizer, this is a demo built by Microsoft. And Personalizer basically allows you to use reinforced learning as a service. So basically a service that learns from your users' behavior and learns what is working and what's not working. And it kind of gets better for each step of use. And for every time you tell it if it was a successful thing or not, it will learn that. So how this service works, and this is a demo based on showing relevant articles to a user. So to begin with, you give it kind of a context saying, in this case, is it a work week or is it a weekend? Is it AM or PM, and what's the weather outside? And this is just kind of what they thought was a relevant context for showing articles to the user. In your case, it might be completely different context. The important thing is that you kind of experiment with things, and probably not. Maybe it's not relevant with what exact day of the week is it, but rather, as they have shown here, is it a work week or is it a weekend? And also then, now I'll show me a personalized article. Then it thinks that, yeah, this article seems to be relevant. And while I'm scrolling here, and this is just kind of a visualization here of how it's going, the more I read of the article, the more reward will be given. So what they have done is that it gives a reward to the machine learning model. The more I read throughout the first 12 or 30 seconds, the more score it will get. So if I show another article, if I were to scroll through this really fast, it will get 100% score, even if there is time left. And then it will learn that, okay, while it's a work week and it's AM and it's sunny, people like me tend to want to read this article. And this is based on possible actions. So you basically have a data set or a database of different articles, and you give them a few features. So for example, how is this a breaking news? What's the news source, and so on. And the cool thing here that Personalizer will start to learn what to show to who at what time and so on. And this could be really useful to create more personalized experiences. And I'd say that if you boil it down, things like this is what's used when you go into a video site, for example, and you get, oh, we have 5 recommended videos for you, or Spotify says what music to listen to, and so on. Let's move on. I used to mention there is another service called Anomaly Detection, and Anomaly Detection allows you to find anomalies within data. So if you have financial data or you have time-based data that usually have some kind of pattern, that service can find anomalies in them for you. And now let's dive into text analysis. As I said before, and that's a common case as I've seen as a consultant, is that you have a large amount of unstructured images. You have images on your intranet in SharePoint, or you have it in a file storage or blob storage or whatever, and you want to extract and find things about them. And a lot of those images might contain text, and the text might be so massive that you want to actually extract what's the kind of key takeaway of this text, and that can text analytics help you out with. So I'll take some. Let's do like this. Here is the event page for this specific session, Democratizing AI with Cognitive Services. I'll try to just copy-paste the description of this one and do an analysis of it. So to begin with, we get some information that this text is in English. It's 100% kind of confident on that one. And the sentiment, it's basically kind of, is it a positive or a negative text? And that is very positive, it says. And then we have a few key entities here. We're talking about artificial intelligence, machine learning. We're talking about Docker, Microsoft Azure. So these are entities not only like words, but entities that they think are specific things. Sometimes it doesn't get this right, because today I was not referring to the American TV program, unfortunately, but it identifies, for example, Active Solution, the company I work for as an organization. And it identifies Peter Orneholm as a person. And the cool thing here is that it's not based on some kind of, it's not based on a database of people, it's not based on a database of organizations and companies. Sometimes they are probably that for the American TV program, but even if you take a small company in Sweden or an unknown person, or kind of semi-unknown at least, it still identifies that as a person because it looks at the context in the text. So yeah, this seems to be written in a way that what is described within these words, that should be a person, or that should be a company. Or if you take numbers, for example, I think we had today somewhere, 10 years, that's a date, time, duration. So it kind of, it knows that 10 in this case, it's just not any 10 digits, it's a date, time, duration. So that's really interesting. Then we get some key phrases. What I've seen is that quite often the key phrases are quite many, but it boils down your text into far less key phrases to work with. And this could, of course, also be used if you want to index large amount of text or large amount of images that contains text and so on, to get kind of fewer keywords, to be able to tag the articles and so on. And so I'd like to show you a final demo that kind of combines a lot of this one. Or actually, I think I have quick time for a last one regarding speech, because I haven't mentioned speech that much. So in Sweden, we have Swedish radio Echo, which is basically the one of the largest news broadcasts using radio. So, and they have an open API, so you can consume their data without actually signing in. It's really easy to work with. And so what I did was actually, I think I have a blog post with a little nice image here explaining how this works. So what this is doing is that it's periodically asking Swedish Radio, hey, are there any new news episodes? It's then using Azure Speech to Text to transcribe those episodes. And these episodes are in Swedish. It's Swedish radio in the end. And then it's translating those into English. It's enriching the translation with text analysis to find keywords and find things like that. Then it's turning that English text into speech and storing the result. That means we should be able to listen to Swedish radio in English. So I'll start the original episode here. Okay, this was a bad example because there were some. Let's take about this one.
Ja, det stämmer. Ekot sänder direkt med en uppdatering kring coronaläget.
And then we could try that in English.
Common, yes, it is true. The Echo broadcasts live with an update on the corona situation in Sweden. It is the Public Health Agency that, together with the National Board of Health and Welfare and the Authority for Social.
So this means that also from accessibility point of view, if you are new to a language, you could technically start to listen to news episodes within that language as well. And of course, there are other ways to use this to identify kind of what language are they speaking, to kind of index and make even audio and video searchable and so on. So let's do the final demo, which kind of combines a lot of services we have seen so far. So this is, I think it's roughly half a year ago or a year ago maybe, that I started doing kind of exploring my heritage and see where I came from and so on. And I was asking my grandparents and my parents, kind of my wife's grandparents and so on, of images and their history and so on. So what I did was I was taking a lot of photos on their photo albums. And I realized, okay, I have a lot of unstructured data. How do I kind of make sense of this one? So it's a lot of images with a lot of text, a lot of people and so on. But using Azure Cognitive Search, that's a kind of a service from Microsoft that combines a lot of these cognitive services into a search service that can search through unstructured data. So for example, if I search for a wedding here, it has automatically identified images where people are wearing wedding dresses or wearing nice dresses. Or there is a photo of a photo, so to say. And here we have, quite a lot of wedding pictures. I can also search for, let me find what the name was. I think it was Anderson. So here we have, no, I don't have that available at the moment, but now I know that somewhere within this picture, there is actually a person named Anderson mentioned somewhere. It's mentioned here. And you can also go on if you want to explore everything, you can see that it has identified, I want to have things where people have human faces, which are tags. I want to do where Allan Johansson. So there is probably, Allan Johansson was mentioned in these two pictures. And this can kind of extract things from audio, from video, from images, from text, from PDFs, and everything like that. And we kind of do knowledge mining on a lot of unstructured data, and that I think is really cool. With that, I'd like to. There are so many more services in Cognitive Services that I could show you, but time is short, and I'd like to have a few minutes to answer your questions. So I will sum up this with the presentation, and I think I had the time to show quite a lot of these actually, quite a lot of these demos for you. What I would like to say is that Cognitive Services is built around a lot of specific services that solve specific scenarios, and it's up to you to combine them in your application for your scenario to build and solve the scenarios you have. So as you see in the end here, we have the radio text that transcribes the Swedish radio that is using 1, 2, 3, 4, 5 different cognitive services. And the kind of heritage application with search through all of the images, that's using 1, 2, 3, 4, also 5 services to kind of identify and make things searchable. And an interesting thing here is that to see what are your needs, what services can make this available for me. And just to sum up what Cognitive Services does, and this is kind of my interpretation of it, is that like 10 years ago when we got the cloud, or maybe it's 9 years ago or something, we got the cloud as a service where usually, or before that, we had to think about service, about cooling, servers cooling, etc. But then Azure came, and instead we could focus on our business value and what is important for us and what drives us forward. And the same thing basically happens now with Cognitive Services, where we have AI as a service, where previously you would have to know a lot about the inner details of AI and machine learning, while Cognitive Services can make it so that you can focus on your business value, while Microsoft can focus on driving the AI and machine learning models forward. With that being said, you should be aware of handling this responsibly. I've given this presentation quite many times now, and most of the people they are fully aware of how they should use it and how they should use this responsible. But there are a few people that kind of, oh, I could use this to do this and that, to do really irresponsible things. But it's up to us who are developers and companies that use this AI to kind of think about fairness, inclusiveness, reliability and safety, transparency, privacy, security, and accountability. So for example, that you are transparent in how you are using AI, and if you are presenting different things with and kind of ordering things with AI, please notify the users about that. Or if you're using face recognition, please make sure that it's opt-in from the user, for example. But also that we should, the same thing as kind of when we are developing applications, you usually have a checklist, kind of, have we done the security test on this one? Have we done the code quality test? And have we done the responsible? Have we thought about responsibility when we are designing and developing and putting this into production, so that we are using it in a responsible way? And this article is in Swedish, but the Pope, I think, in March, he stated that he's warning the world about face recognition and how that it can be used in really bad ways. There is actually a service in Cognitive Services where you can train the text-to-speech service to use your voice. I mean, it was probably not that service being used here, but there are ways of fooling people into sending money by using someone else's voice. We can skip that one. But with that being said, I have 2 links for you. There's a link on the next slide as well. This link leads to a GitHub gist where I've collected kind of link to all of the demos I've done today, link to my social media accounts, and to all of the source code for everything like that. Please take a photo of this QR code or go to this link. And there is also, as I hinted about before, there are great resources in Microsoft Learn, so you can dig deeper into all of the cognitive services. And you can find them on this link, at least a starting point. And there are also great resources from my colleague Alan Smith, who has done videos on specifically custom vision. And with that being said, I think I am done with the session, and I think we should have about 5 minutes left for some questions. So I will bring up the Q&A and see. Yeah, so we have here, I think I'll try to take them from top to bottom. How about a picture with a bird standing on the head of an alligator? Does it work for that? I'll try it. I think there is actually the answer should be yes. Alligator bird. Let's see if we can find any. This one was, let's see what it will tell us about this picture. Bird or not.net. It doesn't always work with. I didn't find the word. It found the crocodile, but not the bird. Let's see if we have some picture with a clearer. This one maybe. So it is a bird, it says, and it says that there is a bird in this box, and this is not a bird. But it didn't actually identify the type of the type of bird or type of crocodile, but it identified a bird and a crocodile. So next up, fascinating presentation. Thank you. Can you train Azure to recognize your voice so it gets better at captions? And yes, you can. So if you have, I think it's called Azure Custom Speech. Let's see. Let's go here then. Features, speech, speech to text. Customizable model. Yeah, maybe it is. Yeah, here it is. So what you can do is to improve the accuracy. So you can start with the generic one. So you can start with the generic Swedish one or the French one or the English one, or yeah. And then you have, in your scenario, you might have specific words that used only within your domain, or maybe you have a person that is speaking a very different accent or things like that, then you can use the custom speech to train on that specific thing. And there is, I think there is a custom speech studio basically where you upload the audio and then it automatically transcribes it, and then you can go in and say, oh, you thought it said the train, but it was actually tall, that was the correct word, and then it will learn from that and get better and better. So you're actually able to do that. There were no more questions so far as I can see, and I know you are probably a minute behind what I'm presenting at the moment, so I'll wait a few more seconds to see if there are any other questions. But otherwise, I'll recommend you to try out the resources and explore the services yourself. And a few of the cognitive services, they actually have demos on the website, the official kind of marketing website as well, so you can try it out there. Yeah, so there was an answer here. Actually, I'm Irish and automatic captions are terrible with our accent. Thanks from Mim in Dublin. Yeah, so it's the same with a few accents in Swedish. It's not very good, so but you can train them to get better. So that's promising. So with that said, I'd like to say thank you for taking your time to listen to this, and I really hope that you enjoyed it. I think I might actually have a link to the community, and please follow me on social media if you'd like to. It's Peter Orneholm, both on Instagram, Twitter, and I'm on LinkedIn as well. Please evaluate this session. I'm not sure if I have an ending slide on the evaluation. I can go back to the first slide to give you that one. So please evaluate this session if you thought it was good, so I know that I should continue doing it. And please let me know if anything should be better next time. I think that's all from me, Emma. Would you like to say some final words?
Thank you, Peter. Yeah, just from me, thank you to everyone who's attended today for your questions throughout as well. It's been a pleasure to have you all here. I will just share with you the YouTube link in the chat now, and that's where this session will be posted towards the end of this week. You can back on demand. But Peter, it's been a pleasure to have you, and hope to see you all again at the next reactive session.
Thank you.